Hello, everybody. My name is Attila or Attila, whatever is easier. I don't know. Yeah. So I'm originally from Brazil, but I'm speaking from Berlin in Germany. And yeah, for me it's good morning. I don't know. For you, I believe it's afternoon. So yeah, today we're going to talk about remixing usability using performance for it. So let's get started. So first of all, yeah, I'm a developer experience engineer at a company called Zata. Zata is in the serverless database space, but we're not precisely talking about database today. What's important is that I'm going to talk a lot about developer experience because that's what I do. And because I'm telling you what Zata is because I want you to just to give you context that for me, developer experience and user experience are the same because developers are my users. Um, so today I'm going to talk a little bit about how the two of them intersect. I'm in the internet as attila.io. You can find this website, and I have some redirects for social medias like YouTube, Twitter, GitHub, even Mastodon at this point, because Twitter is going nuts. Um, so you can find me there. Reach out if you have any comments, questions, feedback about this presentation. I'm always happy to chat. So yeah, let's get started. Before going further into the technical parts, I think it's also important to just structure a little bit what design is. At least from my understanding, I'm not a designer by any means, but as a front-end developer, when we talk about design, I'm thinking about user interface, I'm thinking about user experience, and usually in the circles that I'm in, I see that the conversation kind of ends here, but I believe there's a third component that's extremely important. That's called usability. And now I want to make this little exercise with you for you to for us to understand how the three of them intersect. So first of all, we get the UI, which is we're going to define how the UI looks, the user interface, in the sense of connecting the pieces of that UI together, making what's related close, make like following the Gestalt principles, making sure that the user can understand what they're looking when they're looking at our UI. Then the UX is going to dictate how the user is going to interact with this UI. If this is going to be an ergonomic experience, if this is going to be easy to follow and easy to use. But third, there is also the usability part, where the usability is going to determine if it is possible to use, if it's possible to reach this kind of UX. For example, if our UI has a horrible accessibility, and somebody like if you're not prepared for I don't know, keyboard navigation, and somebody comes in and they don't have a mouse, you don't have a bad UX because you don't have a UX at all. So that's how usability is going to determine. Or for example, if you have a horrible latency, horrible performance, for a certain amount of time, the website's not going to be usable, the app's not possible for the user to interact. That's not bad UX, that's lack of usability. And so that's why I think they intersect. So you need to have some degree of usability in order to have UX, and you need to have the UI in order to be able to do those things. So yeah, this is it. This is what I needed us to be on the same page about for the terms I'm going to use in this talk. And then we can start talking about our websites. So what's going to happen with our apps is we develop them in isolation. Um, we do them in our local development, and they look great. They're stunning, and then we ship them to production. And then the users come and do what users do. They just click around and start interacting with it, and suddenly our beautiful apps look like this, right? So we get these loading spinners everywhere. The user needs to wait, and you know, we could do better. So most of the websites, and to explain that interaction a little bit further, I broke it down into these four lanes. The first one representing the user, the second one representing this UI part, the third one is program, which is essentially the logic inside your client-side app. And then the other one, I added API, but that's more of a umbrella term. That can be an external API, that can be your own API, that can be your database, anything. Just like I could have put server there, but I thought API would be best to describe. But just think anything that's not client side whenever you're going to fetch something from somewhere not on your client side. So what happens that the user is going to arrive and the user is going to fire a click on the user interface. Meanwhile, they already seeing a loading spinner. And then that click is going to tell the user interface, okay, send a mutation event to the logic, to my program. The program is going to then send a mutation request to the API. The API is going to give a response, and that response, we cannot control the time because it depends on the content delivery network. It depends on the latency in the server. It depends on how good the query was. It depends on a bunch of things, even the user's internet connection. So there's no way we can. There's only some degree we can optimize for that, especially as front-end developers. And there's also a high coefficient of things we cannot control at all. And then once a program receives the response, the program is going to fire this update content to the interface, and then finally the user can see something in the screen. So for all this time, the user has been waiting for something to come back from the server. And that's really bad because these are event waterfalls. We know, for now, I think most of you have heard that resource waterfalls are horrible. When we look at, especially when we talk about like Remix, Next.js, this kind of frameworks, everybody's trying to make resources parallel. Everybody's trying to make rendering events in parallel. But we need to also think about the other interactions that we have. And in this kind, we are imposing a big waterfall. And and that means that this green bar by the end of our waterfall is only going to be as fast as the combination of all the other bars combined, which in this case is horrible. We could do better than this, so the user can finally see something. And that's what I'm here to talk to you about. It's about optimistic mutations. So let's do this exercise. Let's try something different now. So the user is going to click. That's nothing we can do about that. The mutation event is going to be fired to the program. And then the program can already, okay, I have the mutation that I'm going to send to the server. So I'm going to give you back, like, show this to the user already. So the user has an instant experience. Nothing changed in the end. We still have the same backend. We still have the same API. Our mutation request is still going. But because we already know the kind of data the user is trying to insert, we can already give them a response and the user can go on. And then 99.9% of the cases, this response is going to be successful. And that's what being optimistic is about. Okay, so we already anticipate that there's a very high chance that this response is successful. So we are going to give an instant feedback so the user can go on. And we're going to do our stuff in the background. So we're essentially parallelizing the data sync. But some of you are probably thinking, okay, but what do I do about the cases that I cannot control? Like what do I do about with those little cases that something's going to happen? Like partitions happen on the server, every now and then servers are down, regardless if it's like a huge conglomerate or a big startup like Twitter's, things go down. Like was last week, I think Twitter had like the 2FA down and people could not log in. So anything can happen, right? So for those, sorry. So for those for those small cases, let's see how we can do to handle these errors. So first the user is going to click as usual. The mutation event comes, we send the update content, the user receives something. Meanwhile, the mutation request is going and the response is not great. There's an error somewhere. So we update the content and then we ask the user, okay, something happened. Can you please, do you want to retry this? Should I send your data again? And things like that. So this is how we are going to handle how we handle errors on an optimistic mutation architecture. So talking about the error handling, it's important that we have some important notes about this. First of all, if those errors are not one every like many cases, you probably have a bug. Maybe your app is not okay with the kind of data your API is giving back to you. Maybe your API has a problem. Maybe you have high partition between the edges of your network, or the API you're reaching out is an external one, and you shouldn't trust it that much, or something like that. That's an indication of a bug that needs to be fixed. The point of the optimistic mutations is to be optimistic about the data that you can control, the data that you can trust, to give the best possible user experience. It's not about being optimistic about everything. For example, there are kinds of interactions that we need to be we cannot be optimistic about. For example, login forms. If you're going to do a login in an email account, I hope your provider is not being optimistic about the password. You cannot show the inbox before you verify the password is right. If you're doing bank transactions, um, you cannot be optimistic about the mutation. So what banks do is essentially they treat every transaction as atomic, which means that if I'm sending money to you, the money is only going to leave my account if there is a place to there is already an account. They already found the account and they can give the money to that account. Otherwise, the whole transaction is reversed. This is called ACID, uh, and this is one of the principles of ACID, and that's important to have data security and data sync. So there is no way that the money just goes out of the limbo, or that both of our accounts have money, and so on. So this is the kind of interactions that we can be optimistic about. So the pending UI is actually a good one in this point. So when should we use optimistic mutations? First of all, when the response is not critical for the user experience. In the database land, we call this eventual consistency. For example, if I have a content, if I have a comment section in my blog, it doesn't matter to the user reading it, my blog, if I present an off by one count of comments. If I have like one less comment than I actually have, or if the comment is showing optimistically but it's still there in my server, or something like that, or likes in a tweet, for example, or in a Facebook page. And most importantly, it's when you can trust the availability of the resource. So when you have control over the database, when you know the things is there, then you can be optimistic. But if it's an external API that you're not sure if the resource is up to date, or if it's something that you're not sure it's there, then you probably shouldn't. So yeah, enough about concepts. Let's talk a little bit about code. So the first demo and examples I brought to you is from Remix. And Remix has two ways of handling the server side of data. The first one is via loader function. The loader function is fired whenever a page is loading, which essentially means it's firing on GET requests, like if you think about the HTTP verbs. And the way we connect from the client side to them, to a loader function, is via a React hook called useLoaderData. And the second action we have is the action function, which fires when a data mutates. And this essentially means that it's going to fire on all the other verbs from requests. And the way we connect with that, there are actually three different ways we can connect to them. The first one we could try is the useActionData, but this is not the one we're going to show because this is not the best one to use for optimistic mutations. It's better to use the other two. So let's talk about them. The first one is useTransition. And if you're a React developer, but you're not a Remix developer, it's important to highlight that this useTransition is not the same hook that you have on React 18 and onwards. There is a useTransition hook that is built in React that is made for suspense and concurrent mode. This useTransition is a Remix hook and it works differently. We have three possible scenarios, three possible behaviors of the useTransition hook. The first one is when we do a navigation. The second one is when our form submission is going to fire a GET request. And the third one is when we have all the other verbs from a form submission. So if the method is post, put, patch, or delete, it's going to be the third behavior. All of them starts from idle, but then things get different. So let's see about the navigation one. On the navigation, after idle, it goes through a loading state. And that's essentially when the loader function is happening. And then whenever it's returning, it comes back to idle. Then whenever there's a get form submission, instead of loading, we have a submitting. And then it comes back to idle again. But for whenever we have a post or any other verb in a form submission, that's going to fire an action an action function. And then it's a little bit different because then from idle, we go to submitting, then we go to loading, and then we go to idle again. So if we break this down, it means that during submitting, it's when the action function is happening. When we go to loading is when the loader function is happening, and then the idle again. So it kind of makes sense, but the behavior is different for the hook. To implement optimistic mutations on React component, that is like on Remix, each page is essentially a React component as well. So to do that, we have just have a React component. We're using two hooks. One of them is the initial load data, the initial data that's coming from the loader function, and then a transition that's coming from the useTransition hook. And then we can define which one we're going to use based on transition state. This is a little bit of a convoluted, contrived example because I'm now going to show you working on a real case app. So if you're following from the link, just come back to YouTube because we're going to have a short demo now. So what we have here is my database. In this case, this is I just use Zeta, the company I work for, because it's more ergonomic for me. But this can happen with any kind of data. We have this little app where I'm going to update here which kind of cuisine I want. And obviously today I want something Japanese. Wait, where's what? Okay, so I want Japanese cuisine, and yeah, let's see if I can have, I don't know. Sorry for the obvious thing, but yeah, let's have sushi. And then I'm going to fire a mutate event. This is going to update first this part over here. And then you're going to see that the transition is still going. And only after that, you're going to see my database. So first I fire, and then it shows in my database, and nothing changes. But this was a little bit too fast. So let me come over here, and I'm going to add a sleep function in my loader. And I'm also going to add a sleep function in my action function. So now it's going to take 5 seconds to do that. So let's try again. This time I'm going to go for Brazil, and I want barbecue. So I'm going to fire this. It's still going, already showing there. And then it shows up here because it's already submitting. And loading again, 5 more seconds. And there we go. So nothing changes. The change was optimistic. And this was it for this demo. So we can come back to the presentation, because now we're going to talk about useFetcher. useFetcher has a similar behavior to useTransition, but this hook actually lets you do interactions in your app without navigating. So this is a full single page application behavior. We send the request, it runs the action function, runs the loader function, and just comes back without the user navigating. To use that, there are like three ways of handling data submission in Remix. The first one being the regular form HTML component. The second one is the one we use for the transition, which is a React component. It's a wrapper on the HTML form element that does some single page optimizations. And the third one is the component that comes from the fetcher hook. This is important because it's connected to the hook, to the fetcher hook instance. So the code we do is a little bit different. What we have here is we use the useFetcher hook, which is going to cap the data, the submission, and the state. Then the food defines if fetcher.data exists, and then we're going to use the data from there. Otherwise, we're going to just use the one from the loader function. And then if there is submitting data, we just show form data is an HTML API. It's not connected to Remix. So this is how you interact with whenever you're sending form data up the pipe. And otherwise, we just show nothing if we don't have any kind of food, if your database is empty. So let's have a look. Back to our demo. Now I'm already showing this here. If I refresh my page, I see the Brazilian stuff. Let's delete this. So yeah, no tricks up my sleeve. And this time I'm going to go straight to my code because we're a little bit on the short end of time. I'm going to add my sleep functions already. Otherwise, my connection is going to be too fast. And I'm going to go again. So let's go for Japanese, and let's go for, oh, bento would be nice. Yeah, go for a bento this time. And then I'm going to submit. It's going to take 5 seconds, show up in my database. Back here, I'm already seeing it, but the loader is still firing. And then that's it. So this is how we go optimistic about it. There is, let's see if we can cause an error, because I have, so Remix is going to fire an error in a few cases. So if it's smaller than 3, no. If it's fire a more bigger error. So German Schnitzel didn't fire the error. So let's go for the next one, because I'm being way too lucky about my errors. First of all, let me take this out and let's see if I can cause an error now. Nope. It's still working. My God. I'm too so let's go. So what Remix is doing, it's if there's an error returning, then we return, then this would be essentially a try catch. So we get it from the try catch if there is this error, and then whenever there is one, we can show on this page here. So do you want to show a try again button whenever the data submission was an error, so you can control this response, prompt the user, and do that. Okay, so and at this point you can even be more granular, because for example, if the error is a 500, there's a high chance your server is down, so you don't want to do that, because there's no recovering from this. So if the error is like on the 400s, if there's a bad request, then you can send back the data validation or something like this. So let me go back to our presentation this time.
Sorry, let me jump in. You are running out of time, so how minutes do you want to use?
I thought it was 25 minutes. I was going to just take 2 more, but okay. Okay, I can close up
2 minutes.
Now. Yeah, I can wrap up in 2 minutes. That's what I was going to do.
Okay. No. You will have 2 minutes to finish your presentation.
Yeah, I had the timer here. I thought it was 25. Sorry, was less than that.
You will be able to continue your presentation to finish your presentation.
Okay.
In 2 or 3 minutes.
Yeah. I just want to show how to do that without any framework. So that's just a state machine, and that's it. Okay.
Okay.
Awesome. So let me go back here. Oops. Now I got confused. Oh, great. This is not. So let me just jump straight up to. I am not. This one. So whenever you're so if you're on a vanilla JavaScript app, you can come over here and you can have a state machine for this kind of stuff. So whenever the user fires a fetch, you have 3 possible ways. If there is an error, you can define if it's going to retry. You can even set to retry automatically. And if there's a second error, you can decide if you're going to pull from the cache, and always comes the way back. So for this one, you can just get this state machine, which is open source, and I already put it. It's on the link of my presentation, and or you can just export it away, and just not signed in. Great. So you can export it away as a JSON and just paste it over in the X state, and that was what I had for this. And yeah, so I'm sorry for the problem with time. My point was you can be optimistic about mutations, and yeah, I hope that was useful for you. So thanks a lot.